All right, how's it going, guys? Great to see you again this morning. Thank you to so many people who turned on their cameras and for all the participation that we got as we're doing this craziness here through distance learning. You get the Practicing Exponents Desmos, which was your classwork today. You started it, you got through a couple problems with your group. Some people got further than others in like the 4 minutes we worked together. But there's one problem on here that I think is kind of just a little bit harder than the others. I've been seeing some tougher answers come back, and also one person emailed me and I started explaining it over comments, and I'm like, you know what? I think I should just film the video and do it because it looks confusing. But once you know the trick, this problem isn't super hard. I just don't want to just show you the trick and then be like, this is what you got to do, because you're like, why? So we're gonna think through it. I think it's just better to film a video that hopefully only be a few minutes here. Okay, so we got number 5, and we got part E right here. So this is the one that I think is the trickiest one here. Again, if you have questions on the other ones, you can send me an email. I can film you a video. I can try to explain over message here. So what we're gonna do is we're gonna take a screenshot of this, and then we're gonna do it over on Notability here. Okay, so I'm gonna go over to Notability, and there we go. This is what we got to do. This is the hardest problem here that I think you got to do for your classwork here, and it's to simplify this one. Okay, so this one's a little bit tricky. You got to know what a negative exponent does, and so this is where to tackle this one, I'd remember that negative exponents are repeated addition. So if I have, negative exponents represent repeated division, not addition. Did I say addition? I meant repeated division. Okay, so positive exponents, repeated multiplication, that's stuff you should be familiar with. Like, here's an exponent, you take something to the 4th power, it means you multiply that thing, that base, you multiply it 4 times in a row together. You take a base, right, a number or an expression or whatever that's in parentheses or whatever, you take it to a certain negative power, then you divide 1 by that base, that number of times, or by that negative number is -4, you're going to divide by it 4 times here. Okay, so anyways, this is a little bit tricky to actually kind of reason through. That's why a trick is a little bit easier, makes it a little bit easier to do this problem. But let's see if we can arrive at something and maybe suggest a trick here at the end. Okay, so if we remember that we have negative exponents, and negative exponents are a shorthand for division, what I'm going to do first is I'm going to change y to the -2 power to 1 over y squared. Okay, 1 over y squared. So that's still in the numerator. That's still in the numerator of the fraction. And here's where, like, I think it gets confusing me, what gets overwhelming is that here, what I did is I changed, right? I'm changing this numerator into a fraction, but I'm leaving that fraction in the numerator of another fraction here, because the original problem is a fraction to begin with. So this gets really messy. Maybe I'll undo this here. So here, y to the -2 power is the same as 1 over y squared. And then y to the -3 power, I'm going to change that, because y to the -3 power doesn't mean multiply y times y times y. It means divide by y, divide by y, divide by y. So I'm going to take 1 over, right? Remember, this is just 1 y to the -3rd power. This is 1 y to the -2nd power. So you're going to leave it the 1 there and then divide by y twice. Leave the 1 here and then divide by y 3 times. Okay, y 3 times. Okay, so that's how I'd start thinking about the problem based on the way that I've kind of explained negative exponents, and you guys have kind of investigated exponents so far. So now we need to work and massage this thing here to figure out what this simplifies to. So that's why I'm glad we kind of went over this in class a little bit here, because what I'm going to do is I'm going to move this down here so we can maybe look at this in terms of division, dividing fractions, okay, which is what I kind of talked about kind of quickly in the video earlier today. So this here, right, y to the -2 is 1 over y squared. Y to the -3, the denominator here becomes 1 over y cubed. So maybe let's look at this as knowing that this symbol, right, whenever you have a fraction, this symbol right here means divide. Okay, it means divide, right? It means the division symbol. So check it out here. The division symbol is just a fraction bar where the numerator is a dot and the denominator is a dot. Ah, yeah, you ever noticed that before? Division symbol, right? 1 over y squared divided by 1 over y cubed, right? 1 over y cubed. Mind blown, mind blown. The division symbol, right? It means set up a fraction, right? Set up a fraction, okay? So what I'm going to do is I'm going to bring this down here. I'm going to rewrite this in an equivalent way, because remember, this just means divide. So I'm going to rewrite this as 1 over y cubed, because that's in the numerator of the fraction, right? If you have 5 over 4, right? 5 over 4, that means 5 gets divided by 4. right? Numerator gets divided by denominator. So I'm going to write 1 over y cubed, and I'm going to divide by a fraction here, which is 1 over y cubed. Sorry, it was 1 over y squared is in the numerator. So 1 over y squared divided by 1 over y cubed. That's the same thing as what I wrote here. And this is the same thing as what I wrote here because negative exponents just mean repeated division. Okay, so now I have this here, and this is where I wanted to practice this in class, and I showed this to you in class. I wasn't even planning on it, but we showed this to you here. The easiest way to think about how to do something like this is to think about it in terms of dividing fractions. And if you remember the rule to dividing fractions, most people are pretty good at this. Like you learn this as a trick. There's a fun little YouTube video actually on this. Flip it. I mean, remember the flip it video? It's like sharks and stuff. Anyways, you change the dividing fractions. You flip the fraction, turn it to multiplication. That's how you remember doing this. 1 over y cubed. If we're going to divide it by 1 over y squared, if we're going to divide it by 1 over y cubed, that's the same as multiplying it by y cubed over 1. Okay, y cubed over 1. So now we can multiply our fraction. Okay, so what we're going to get is 1 times by y cubed, which is just y cubed, and then we get y squared times by 1, and that's our denominator. Remember, multiplying fractions, all you got to do is multiply numerators together, and that's your product. You're the product of the numerator, and you multiply your denominators together, and that's the product of the denominators goes here. And there, we've arrived at our final answer, okay? So I just went on and talked about that for, let's see how much time I talked about that for. Because we're gonna talk about the shortcut in a second. So we're gonna figure out like how you can do this super quickly in the future. Because you don't wanna spend as much time as Mr. Fortin just talked about there. That was about 6 minutes. Oh, geez. Okay, so think about this. How can you make this shorter here? Let's notice here, wait, this is how I started my problem here. And you're telling me it's equal to this? You're telling me it's equal to this? So let's check it out here. Let me maybe break it apart right here, okay? Y to the negative 2 power over y to the negative 3 power. We did all this work, reasoned through it. Hopefully you followed it here, right? Step 1, this means repeated division. So this means repeated division. So I'm just changing it in the places that we're at. Then I changed it from a fraction over like numerator, fraction, denominator. I changed it to a fraction divided by the denominator there, divided by fraction, rewrote it that way, flipped it to multiplication, right? Flip, and then make it multiplication. And then I got this as my answer. What do we notice about what we started with versus what our answer is, which is right here? Okay, what do you notice here? What happens? Okay, what happens? Well, what happened was we simply took y to the negative 2 power. That's the same as 1 over y squared, right? 1 over y squared. So when you have a negative exponent, you can just, in a numerator, or say it's like just a whole number or whatever, or a whole expression there, it's not, there's no fraction you see, you just take that negative exponent, move it to the denominator, and make the exponent positive. If the negative exponent is in the denominator, what you do is you move to the numerator and make it positive. And that's it, right? That's all you got to do, right? That's all you got to do, okay? So negative exponent, move it to the different position, right? If it's in the numerator, move it to the denominator, make it a positive exponent. If your negative exponential expression is in the bottom, in the denominator, you simply move it to the numerator and then make the exponent positive, okay? And we can look at this, maybe chunk it up here too, right? Remember, this is the one that tripped us up, was something like this. If we have this right here, that's the same as 1 over y cubed, okay? And then as we talk through in class, this is tough. This is a numerator here. This is a denominator of a denominator. A denominator of a denominator goes to the numerator, okay? If you were to simplify it, okay? If you were to simplify it. So this would just equal y cubed. So 1 over y to the negative 3 powers is the same as y cubed, okay? And this is the part here where I like to go to this to show people this. This is the same as 1 divided by 1 over y cubed, and that's the same as 1 times by, right? We flip this part, y cubed over 1, and right, the 1's cancel out, and this is y cubed here. Okay, that's that. Hopefully you get it. There's the trick, right? Here's the shortcut. Remember this shortcut here, okay? Hopefully that makes sense. And maybe we can do one more as an example if you want, right? Do one more as an example. We got, how about this one? How about z to the negative 8th power to z to the negative 3 power? Okay, what's that? Well, that's just going to be z to the 3rd power over z to the 8th power, right? I can simplify it that way. And with this one here, because we have common bases, here the bases were different. We had a y. Oops, wait, were these all y's in this problem? Oh, I got to simplify this too. Oh, okay. Wait, my answer here is going to equal y, right? Because this is y to the third power over y squared. And so now I just got to subtract them, and then it equals y. So anyways, there was a faster way you can do that. You could have done this. You could have done -2 minus -3, which would have been +1, right? Oh man, I made this video so complicated. Let's check this one out here. This is probably how you did it, actually. Y equals -2 over y equals -3. The fastest way to do this, actually, is to think about this. If I'm dividing, then I subtract. If I say I have a common base, if I have a common base, I subtract the exponent. So I subtract this exponent from that exponent, right? Remember that. If I had y to the 8th over y cubed, 3 of the 8 y's get canceled here, so I'd end up with y to the 5th, right? Which is the same as y to the 8th minus 3 here, right? And I would get this if I do y to the -2 power over y to the -3 power. This would be y to the -2, and then I got to take away that -3 that's in the denominator. And here I'd be subtracting a negative number, and that's the same thing as addition. So that would equal y to the -2 plus 3, right? This would become a plus, okay? And this is going to equal y to -2 plus 3 is 1, so y is our answer to that one, okay? So the good answer, right, the best answer here is y, and hopefully you see why, and I've looked at it a few different ways. I'm going to stop blabbering. Hopefully it makes sense now. Thank you for your questions. Thank you for watching, I guess, and hopefully you have good rest of your Monday. Take care, guys. Bye.